Welcome to Studio RM 2.0. This is our most latest release, and you can see that it has had quite a major facelift. Besides the pretty colors and new icons, a handful of new processes have also been included in this release. In the implicit modeling scene, we have a new tool called faults, and upgrades have been made to the categorical and grade shells, which we won't be going through this webinar today. There are other features such as Concrete, which has been released to all users if you do upgrade from Studio RM 2.0, and we highly recommend that if you have your estimation set up in Estima to flip them over in Concrete because you have accessibility to that estimation technique now. In regards to implicit modeling, that's why we're here. Obviously, we are not the Tesla. We are your friendly, affordable Toyota hybrid. The tools here that we have will do the job. It will take a little bit longer. You kind of have to set it up put a little bit of effort setting it up, but it is part of the package, so it is accessible for you to use. You don't have to pay an arm and a leg for it, and the files that we generate within Studio RM can be used into Studio RM, so you don't have to be converting one file set into a different file set. Now, in implicit modeling, effectively, instead of creating strings and then linking them up and generating wireframes, we're effectively just taking our drill hole database, selecting samples, domaining or flagging them to be utilized in the generation of the wireframe that we want to use. In order to do that in Studio, the two tools that we have on hand is group and assign. And once we've grouped and assigned our domains, we use our contact surfaces and veins. Before I do a deep dive into that, well, the basic dive into it, I'm going to quickly show you what we can do with our new faults tool. If you already have pre-existing strings, what you can do is reference them and build your faults accordingly, but I don't have any, so I'm just going to create a new one. And I've got new faults. You have options for boundaries, none, proto, and custom. None is not using any boundaries, proto is using your block model, and custom is when you generate a polygon. I'm going to leave it at none, and I'm just going to quickly create a new fault, and I'm going to create my string for it. So let's say this is my new string here. If I rotate that, I don't have any wireframes as of yet, so this is unique to when we're using a none boundary. We actually have to go down to extents, and we need to project how far our wireframe generates above and below the string that we've created, like so. So there we have our fault, and if we move our points around, our wireframe will move with us accordingly. If you know the dip of your wireframe and you want to use it, you can type it in and then just push it down, and what you'll see is that your fault will honor whatever dip that you've got allocated there. I'm just going to quickly turn this back to 90 just to set my default. I'm just going to quickly create another fault string, and let's say it goes across and it intersects that wireframe like so. Oop. And I have to do the same thing and project it above and below. So let's say my F2 fault, that's what it's called, is truncated by F1. In the extents, I can choose to terminate that wireframe on, and you can see that F2 is now flush against F1. So there is a fair bit of adaptability in through there. So that is our faults tool. Just a quick look at what we can do, and I'll leave that to you to play around. It's a little bit self-explanatory. If you need additional help, feel free to contact us on the support portal. Now, for the grouping tools and the surface tools. In order to utilize them, we need to have a draw hole file loaded into the 3D viewer. Just going to go to projects and pull in this file that I have on hand. Now I'm going to domain or flag my samples, and with group, when we're using it, we're effectively using a field that already exists in the drill hole file, and we're grouping them together into a new domain. So I'm going to click group. This is the interface that will pop up. So it's picked up my drill holes, it's picked up my lith, and it's asking me to create a new field in my drill hole file. I'm going to call it regional geology. Once I create this new field, I just click into this column here called ungroup, and then this now becomes active. So it's colored all my lithologies based on the colors that are allocated here. You can go in and change them however you want. Once you change it, if you hit apply now, the changes will carry over. But to create the groups that you want to assign to it, you just click new. I'm not too interested in creating too many, so I'll just keep the one. And let's say that I wanted to group my basalt and my breccia into an igneous field. So I'm just going to make it a hot pink so that everybody can see the changes. But effectively, once I create that new group, I just need to select the lithology I want to bring across and choose the lithology I want it to go to. So there's my breccia, and then there's my basalt. And when I hit apply now, you can see it come across. If I hit save file, it will simply save the changes that I've made. And if I go in and have a look at my palettes itself, you can see that I have grouped my data like so in my regional geology. And those that I have not grouped just have simply honored what was in the original list. So that's the grouping tool. So you effectively use it when you have an existing field and you just want to combine those fields together as one. Now, if you are using assign, so assign lets you selectively pick samples to code into a domain that you see fit. So let's say that we're creating a new domain based on high grade assays. We can use assign so that we can individually select the samples to code into the domain that we want. Now, to use assign, we actually have to have a pre-existing field in the draw hole file to code into. So in group, it created a field for us that we then named regional geology. The assign tool doesn't have that capacity, so we have to go into our sheets tab, right click on our draw hole file and go add column. And I am going to add a OR field. It's going to be numeric. It's going to be in this draw hole file. I'm going to click OK. And I'm just going to save it. It just means that when I go and open up that file, you can see that I have a new field and it's empty. And I am going to code into this field. Once I've done that, then I use this tool. So I'm going to click assign. I'm going to assign into the all zone. There is currently nothing in my all zone, so it's just shaded out as gray. Obviously, I want to go in and, select certain samples, but I don't know where my samples are. So we just have to apply a simple legend. So the legend I'm using is one I've made previously for this webinar, and it will display my draw hole samples and the intervals. And it's getting the color red, and I suspect we are referencing the wrong field. So I want to reference OR. Okay. So I've prepped my data so that it will visually look the way that I want it to. And I'm just going to align to view, open up the clipping so I can see what is going on. So let's say I've done some basic interrogation of this data set, and then I have come to the conclusion there are two domains here, a high grade and low grade domain. I'm going to create the name of the new domains. And let's say I'm going to have domain 10 and domain 11. And domain 10 is going to be my high grade, so I'm going to turn that into a hot pink. And domain 11 is my low grade, so I'm going to turn that to blue. Once I have the domains, I can then code into them by selecting the samples that I want to code into these domains. Make sure we clicked on select mode, and when you toggle over the samples now, click the domain, select mode. When I toggle over the samples and select them, I have the capacity to assign or unassign to that domain. Now, in terms of the selection, right now I have this swipe tool, and if I scroll in, it opens up the swipe, and if I scroll out, it closes the swipe. If you don't want to use the swipe tool, if you go to home and you click swipe selection, it changes it back to the box. And if you click it again, it takes you back to the swipe. There is a quick key for this, and it is S for snake, M for monkey, and T for toggle. And that just lets you switch between the two selections. I'm going to keep on the swipe because it's easy. And let's say I am interested in having these high-grade samples live in domain 10. I can assign. If I've decided I've made a mistake, I can select the sample and click unassign. And obviously we would go through and assign the samples to whatever domain you want it to be assigned to. Once all of that is done, all you need to do is hit apply now and save file, and that will save those changes or those selections in the file itself. So if I was looking for domain 11 in this field, you can see that these samples have been coded to domain 11 or domain 10 accordingly. So that is how you can use the assign tool to domain. Create the field that you're going to code into first, and then use the assign tool. I won't code the whole thing. I don't need to. I think that's sufficient enough for you guys to figure out how to use it. And I'm going to click close. Now, I'm going to use contact surfaces. Contact surfaces and veins, to use these tools, you need to make sure that the drill hole file is loaded into the 3D viewer. If the drill hole file is not loaded into the 3D viewer, you cannot use these two tools. And I'm just going to clear my screen and redrag my file again, just to make things a little bit cleaner. So in create surfaces, we typically recommend this for when you want to create a single surface. So really good for weathering profiles. So if you logged oxide, transitional, fresh, I do recommend people use this to kind of get a quick and easy surface. I'm going to demonstrate this on the lithology field. And my younging, so anything in my lith that is sandstone, siltstone, and soil is going to be young, and below and older, which is below, will be my basalt and breccia. And whatever that contact is, you can see that I now have points that define the contact between these lithologies based on how I've ordered. Now, with implicit wireframing, the wireframe is purely controlled by the samples we're using and the parameters that we dial in. If I accept the defaults for what they are, and let's just create a new surface. Yeah. And I am going to create a new surface. You can see I get a wireframe where my contacts are. Now, if we look at the parameters that we can play around with, we effectively have sample, snapping, boundary, and faults. So with edit samples, you can choose to ignore samples if you decide that it is not relevant and make that disappear, or you can use the sample but reverse it so it takes not the hanging wall but the foot wall of the contact. I'm just going to ignore it for what it is. You can also add additional points. So if you feel like you do not have a sufficient amount of data, you can add new points, and it will be not that way. But if you add the points where it makes sense to add those points, and I'll just quickly do it here, and where it makes sense to add those points. Let's say I've got structural data that says that there is a bit of a syncline there. And this is, let's say, version 1 of this. It will go ahead and incorporate that point. In terms of snapping, you do have a fair bit of control of how you want to snap. In through here, we have the points all within the draw holes, but if you have incidents where your contact points is at the end or at the start, you have options to snap, ignore, or pass above and pass below. In regards to boundaries, so boundaries effectively control the extent of the wireframe itself. So we have the default of a line square. And what a line square is that it takes the minimum maximum coordinates of the data set and then gives an extension radius of 40. If I was to do alpha shape, effectively what is happening is, just imagine for every drill hole there is a circumference of 49.8 meters, and that's where the wireframe will generate. And if it overlaps with another drill hole, then the wireframe will stitch together. The extension radius is the distance from the last set of holes along that bounds your data. In this case, if I dropped that down to 20 and I made this version 2 and I go new surface and hide the previous one, you can see that the extension radius has pulled in, but then because the segment length is still the same, everything stitches up nicely. Custom is if I decide to create a custom boundary. So I'm just going to change my section to flat so that I can create a flat boundary. And if I was to generate a new surface, it will generate within the boundary that we create. And if you have a block model that you want to use, you can reference the block model. The wireframe will generate to the proto of the block model. And you can also choose an extension distance, so how far beyond the block model you can use. So if you know that your resource geologist is going to code in your weathering profiles, you can steal the block model and make sure that the wireframe is made past the extension of the wireframe, the extension of the block model itself. On top of that, we also have faults. So if you have a fault running through your data set and you reference to use it, the wireframe will split accordingly to honor that. And that is what effectively contact surface is. Pretty useful for certain scenarios. I'm going to close this and I'm just going to get rid of my wireframes because I don't need that anymore, and also my strings. And now I'm going to click on veins. So the veins tools, effectively, when you use this, you're creating closed solids. It's smart enough to do one kind of domain at a time, but if you have domains that are adjacent to each other or flush against each other, it's still not quite smart enough to understand that interaction. So all wireframes created by veins are standalone individuals. To use this, obviously ensure your dataset is loaded, reference your drawhole file, reference the field you want to create the wireframe of, and then reference the domain that you want to use, or in this case, the lithology. So let's say I want to create it for the breccia. This should look quite familiar, the parameters, because we had the exact same ones in the contact surface. And what I'm going to do is accept the defaults for what they are. And I'll just hide them for a second because I'm not using any of them, just to make a view a little bit easier. And I'm going to generate both. So when I choose both, I'm generating a closed wireframe. You can generate the wireframe just to have the hanging wall or just to have the footwall. I'm going to compute new. And what you see here is a closed wireframes, and I've got little gaps, so I've pinched out a bit. Let's say I want to make some adjustments so it looks a little bit prettier. Edit samples. It's pretty much the same as the contact surfaces. You can pick your samples, and right now your samples is the interval, so you have your hanging wall and footwall. So you can pick your samples and you can decide not to use them, or you can choose to use them but reverse them, so that will cause a pinch out. I'm going to not do any of that and just keep it for what it is. If you choose ignore gaps, all that basically means is that, let's say I don't have the scenario in this data set, but let's say I had breccia here, then sandstone, then breccia, and I wanted it to honor the first instance and last instance and ignore the gap. So this would be my hanging wall, and the other interval would be my footwall. If you choose ignore gap, it will ignore that gap in the middle and take it as the whole. Additional points, self-explanatory. If you want to use it, you can use this button, and that will allow you to add a footwall and hanging wall sample at your leisure. You can obviously add just hanging wall or just footwall, or do both. The boundary parameters are the same as the contact surface. Faults, you can use faults same as the contact surfaces. And the one parameter that additional parameter that we have that is unique to the vein is controls. So this allows you to control the minimum thickness, the maximum thickness, whether you want to remove below or expand to. The reason why I had holes was that I was removing below a minimum thickness of 0.05. If I choose to expand to, I shouldn't have any more gaps. And right now that boundary thickness, you can see that it's pinched out to 0.01, so I think that's 10 centimeters. But if I was to change that to a meter, it would pinch out to a meter. Your resolution is just how detailed it's going to be. So very high is obviously highly detailed, low is very poorly detailed. But if you go very high and you get and it's well detailed, it just means that the runtime becomes longer. So it's up to you as the client to know what is going to be material for you. I'll just leave that alone as medium. I'm just going to hide this from the screen, and if I accept everything for what it is, and let's call this version 1 and compute new. Because I've changed my controls, I should see a different boundary effect. So I have that iteration here. Now the other outputs you can have, besides just exporting the hanging wall and the footwall, is if you're running an estimation and you're using DA and you need a trend surface, you can spit out your trend surface like so, and you can also spit out the boundary of your wireframe if you need to, and the contact points. So the contact points is simply the hanging wall and footwall points. If I spat out all of these, what we would end up getting is the following. I'll just hide everything. So the trend surface is simply this output here. So you can see that it's trying to honor the midpoints of all the samples. So this is a nice surface to use for DA. The boundary is simply the boundary of the data set. So this just gives you a nice polygon. And then for your contact points, you effectively have, if I close this guy for the time being, you can see that it is showing my football points and my hanging wall points. So if you lost everything and you lost the drill hole file, I guess you could use this as a point cloud and try to generate what you had previously. But yeah, that is effectively a quick run through of some new tools, some old tools, and little tricks to utilize the vein tool. And that's pretty much it.